So let's talk about deployment options for storage, replication traffic, or backup traffic. As you are aware, there are two cases for storage arrays or storage filers to interact with an IP network. There's either FCIP traffic, which you can use a Brocade device or a Cisco MDS device to convert fiber channel to FCIP, or you can have native IP from the filer or from the array. Those two types of traffic end up in the core network, and then they get sent across the WAN to the other side, and then there are various acceleration techniques that you can use to make sure that the traffic gets to the other side faster. So I'll start with a simple diagram for a typical data center network, and I'll talk about the various insertion points for these acceleration devices. So let me start with an assumption that we are receiving fiber channel or IP traffic, or standard, this kind of TCP or IP traffic coming from an array or a filer, and they end up in the core network. So a typical network looks like this. There's typically core switching connected to WAN routers going out to the WAN, and of course you have resiliency built in, so you have resiliency right there. So that's a typical network. Now, what the easiest point in this network to deploy, say, a WAN optimization device for acceleration for storage replication would be right off of the router, right here, of these 2 points in this network. Now, the issue is, the very first issue rather, is how many devices do you need to, let's say, accelerate 10 gigabit traffic? So the biggest box from the biggest player in the WAN optimization space, runs at about 700-800 megabits or so. Assuming that math, you need about 14-15 boxes to accelerate 10 gigabit traffic. So really what you have to do is figure out a way to load balance traffic such that when it's traveling on these two paths, you have enough devices hanging off of here to be able to handle that much traffic. This is a very painful process because you have to kind of build a policy on the routers to make sure their traffic goes to the right place. If there are any asymmetries in this network, so asymmetry is an issue that all networks have to deal with, especially if you have multiple WAN links, which is very typical. What happens is traffic that was coming in this way, in the middle, decides to come through this way. This is perfectly acceptable. This is how networks work. But the issue is, when this happens, the devices that were managing this traffic previously, they get confused because they don't see traffic anymore. So you have to build this whole overlay network to make sure that doesn't happen, etc., etc. Very painful process. Not just of course, there's a cost aspect, which is you need to buy 14-15 devices per 10 gig. It's very expensive, very costly. It takes a lot of time to manage, to deploy this. It's very painful to manage it. There's much easier ways to do that, and that's how our system works. So let me draw a very simple way of deploying our devices in this network. So I'll use a blue marker for this, so it's easier. I mean, the easiest way would be, we hang off of these two routers, right here. Single box, 10 gig. You don't need 15 boxes from somebody else. Buy one single box, 10 gig. If you want high availability, no problem. One more box and you're done. You don't need to worry about asymmetries. You don't need to worry about this overlay network to make sure these boxes can talk to each other. You don't need to worry about load balancing. Just hang our boxes off of both the routers, both the WAN routers. Problem solved. This is out of path. Of course, in this case, you do require some policy on the router to make sure traffic gets to us. But it's very non-intrusive. If there's anything wrong in the network, no problem. Traffic just goes through. There's even a better way. If you would like to try out something which is more in line with the traffic, and that works as follows. We can deploy our boxes right here on the trunk. There is no such thing that can do that in this market today. We can sit on this trunk and we can look at all your traffic in line. The box has been designed with a switch fabric which can actually handle 160 gigabit. So we will never be a bottleneck in your network. Even if you send us 40 gig, whatever, doesn't matter. Our boxes will they stay strong. They'll keep processing the traffic that they should. Basically what that means is they will identify the 10 gigabit of traffic that they should be accelerating. The rest just goes through and they continue their merry way. You can put them right here on the trunk, or it could be a layer 3 network. And at the same time, there's no complexity. Just plug one side in, or the other side in, and you're done. There's no policy changes on the router. Nobody even knows we exist. It's a very clean, pristine solution. That's number two. It gets even better. If you really, if the team that is purchasing the equipment is a storage team, and they would rather have these boxes deployed much closer to the array, no problem. We can do that too. So for traffic coming in from the array, what we could do is we could just basically sit right here. So we can literally sit right next to the array. We can be in line with the array, or with the switch that's aggregating all the traffic from all the arrays, and we can just expert traffic right there and then, right at this edge of the network where the SAN meets the LAN, if you will. The big advantage of this kind of deployment is that if the biggest issue in your network is your storage traffic, if that's the traffic that is driving up all the bulk of the traffic in your network, what you can do is before it really hits the core network, you make sure that that's been reduced. So if you deploy your boxes right here, by the time this traffic gets into the core, it's already reduced, which means that you don't have to worry about making sure that there's enough availability in your core network. You don't have to worry about any of that because all that traffic is already reduced. None of these things, what you see in blue, the close to the array or in line in this network, or kind of hanging off of these two routers. None of this stuff can be done with anybody else. Of course, we had to think through a lot of these deployment examples, and we made sure we deal with all the scenarios that we know exist in data centers. Plus, each of these boxes can run at 10 gig, so a single box can do 10 gig versus having to require 10, 15 boxes from anybody else to do the same thing.